Okay, guys, so what we're covering today is we're starting Chapter 1, 1.1. So this is probably one of the few classes you're going to have that's going to have homework on the first week. Not, I bet someone's beat me to it, but all right, because what we're talking about is rectangular coordinates. You guys, we've done rectangular coordinates more times than you can count. Because all this is talking about is like an XY coordinate plane, Cartesian coordinate. So something like this here. So just as we can represent on a number line, we can also represent it in a quadrant. 1, 2, 3, 4. 1, 2, 3, 4. And it's always going to go in this kind of counterclockwise motion going in this direction. So x and y are both positive, it's in quadrant 1. If x is negative and y is positive, it's in quadrant 2. If both of them are negative, we're in quadrant 3. And if x is positive and y is negative, it's in quadrant 4. Nothing new yet? Most of the stuff we do in Chapter 1 is probably going to be some stuff that's not that new. Horizontal axis is x, vertical axis is y. We can divide the two, each is in xy. X coordinate, I mean, this is stuff that you guys have done at this point, yes? If we want to plot a point, we go over on the x and up on the y. Or we can go up on the y and over on the x. So here, if I want to plot the points negative 1, 2, over here, on this here, well, I would go over negative 1 and up 2, and then make a point. 3, 4, I would go over 3 and up 4. 0, 0 is just at the origin. We can go 3, 0, and negative 2, negative 3. Nothing new yet? And that's it. That's all we got to do to plot points. And it has them all listed out here, but the beauty of a rectangular coordinate system is that it allows you to see the relationship between two variables. It'd be difficult to overestimate the importance of Descartes' introduction of coordinates in the plane. Now, these are going to be our two kind of main formulas. Our first one's Pythagorean's theorem. We know Pythagorean's theorem, a squared plus b squared equals c squared. And it helps us really find the sides of a triangle. Here, so a squared plus b squared equals c squared. And we can find it for any triangle, a, b, and c, where c is always going to be the hypotenuse. C is always going to be the hypotenuse, no matter what kind of triangle we're dealing with. So suppose we have this here. Now, if we're given any kind of points, so 3 points in a triangle and determine information about it, well, we would need to find the distance between them. And so what they're going to do here is y2 minus y1, the absolute value. We're just subtracting the two values from each other to get that value. And this works great as long as it's along a straight line. The length of the vertices of this here is given here. By Pythagorean's theorem, we can use this here and get this. Now, if you notice something, this should look familiar. You know what that looks like? You know what it is? It's the distance formula. So the distance formula really comes from the Pythagorean theorem. That's actually how they get it. They don't normally talk about it that way, but that's really what it is. So we also have the distance formula. And unfortunately, everything I write on this whiteboard is not going to show up. But these are two formulas that are important because we're going to use them. That's actually most of what your assignment's going to be over, is really doing the distance formula and this and figuring out which quadrant it's going to be in. So, looking at this here, if I want to find the distance between these 2 points, we're just going to use the distance formula, yes? So we'd say the distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So what would be an x1 or x2 value? 3. Our x1 would be -2. So our y2 would be 4, 1. Now at this point here, you can plug everything in the calculator. You can plug that whole thing in the calculator and give you the answer. Or we can solve it by hand. And if we solve it by hand, we would do 3 minus -2. Well, that's the same as 3 plus 2, which gives me 5. 4 minus 1 is 3. Equals square root of 34. Because if we want to reduce this down, we would look for perfect squares. So the first perfect square we have would be 4. 4 does not go into 34 because it would be, let's see here, it's 36. 32 would be the closest one. 4 doesn't divide into 34 evenly. The next one after that is 9. 3 and 4 added together is 7. It's not divisible by 9, the divisibility property. Then after that is 16. It's not going to divide into 16 or 25. So this thing doesn't have any perfect squares in it. We could reduce it, but if we reduce it, we get a decimal. Unless it specifically says to round to 3 decimal places, leave it in simplest radical form. Simplest radical form is going to be the best way to leave it. Okay? So I would leave it as this here. So these here don't have a number on it, but maybe that there. So I would use a TI-30XS, one of the ones there, because those will reduce if it is possible to reduce it. So if you're curious about does it reduce, I would use that one there. The graphing calculator will always reduce it down to decimal form unless it reduces down to a whole number. It will not put it in simplest radical form without doing a lot of complicated stuff with graphs and working that way. But that's it for this one here. Questions on this here? Do we need to see another example of finding the distance between 2 points? So we'll use it again, but in a different form. So we do this here, we plug our numbers in, simplify, and then if we use a calculator, it comes out to 5.83. Questions on this here? Now, if we want to use the Pythagorean theorem to check the distance is correct, we can. Because what this is saying, and if I can extend the page. Yep. It's always going to be a little off. Yep. So if we use our points, I'll come back here. So 2, -1, and 3, 4. -2, 1, 3, 4. This here, finding the distance, what we're saying is this distance and this distance ends up being our 5 and 3. So 5 squared plus 3 squared gives us that overall distance, which would be our 5.83. That's it. Does that kind of see how those two connect? I mean, it's a way to check it, but it's not essential to solving the distance. Okay? Any questions on this here? Okay, now, the reason that this is blank is because I'm actually adding this in. If for some reason the book skips, or the slide skipped example 4, if I want to do example 4. So, I'll write it down here. So we want to that points 2, 1, 4, 0, and 5, 7 are vertices of a right triangle. We want to show that these are vertices of a right triangle. Now, there's two ways we can go about doing this. One is graphing it, and graphing it's fine if we want to visually see it. But what do we know about a triangle given 3 points? All 3 of these points will connect, yes? And if it is a right triangle, then a squared plus b squared equals c squared, yes? So if I want to graph it, I can graph it. I don't have to, okay? Is what we could do is I can take the distance formula from here to here, and here to here, and then what? From here to here. Because that would give me the 3 sides, because all 3 of these sets of points will connect. And it doesn't matter which order I do it. It's just saying that those 3 will work together. So I'll show you the graph here. 2, 1, 4, 0, 5, 7. So that's what we have here. And we're finding those lines. So we can do it, we can graph it and then do it, or we can just do the distance formula. It doesn't matter which. So we can do this here. So we take the square root of what? Four minus 2, so we would do our x values squared, plus 0 minus 1 or 1 minus 0. It doesn't matter which order we do it, as long as the x's are together and the y's are together. That's the only thing that really matters. So we'd have 4 minus 2 is 2 squared plus 1 squared, which is 4 plus 1, which is equal to the square root of 5. So this distance here, I'll write in red, is square root of 5. So that's 1 down. Now we're going to do a second one. So we'll go from here to here. So this time we'll do 2 minus 5 squared plus 1 minus 7 squared. So 2 minus 5 is negative 3. 1 minus 7 is negative 6. Well, 3 squared, well, negative 3 squared is still plus equals 45. What number will divide by 45? That we like. Well, 5. 45 divided by 5 is 9. It's 9. Is 9 a perfect square? Square root of 9 is? Square root of 5. 3 square root of 5. And last but not least, we got one more. Now, I'm going to go on and erase this because I just don't have room. So the last distance, if at any point you need to go back and rewatch some of this stuff, you can do that. There's no problem. Scroll back. Is these, let's see, we did these two, now we're doing this one. Yeah, so we're down to the last one. So 4 minus 5 squared plus 0 minus 7 squared. Well, 4 minus 5 is negative 1 squared. And we have negative 7 squared. The negative 1 squared is 1. 7 squared is, which would give us the square root of 50. 4, 0, yep, square root of 50. So we found the 3 distances. Now we need to determine if it's a right triangle, yes? Now, according to what we're doing here and how they want us to do it, is they want us to use the Pythagorean theorem. So, which one of these is going to be the hypotenuse? we know that this is not going to be the biggest side. Convert that to a decimal. So second square root of 50. So it's 5, actually it's 5 square root of 2. 7.07. Do 5 or 3 square root of 5. See what it is. So this here is our hypotenuse, going from 40 to 57. So let's use it as the hypotenuse. Don't use the decimal. Let's use the square roots. And there's a reason why. So we know that our A is square root of 5, and it will be squared, yes? Plus 3 square root of 5 squared equals the square root of 50 squared. Well, wasn't this really the square root of 45? Yes. Now I'm going back to that because it's going to be easier to work with for this one here. Because what's the square root of 5 squared? It's 5 plus 45. Is it a right triangle? Yes. Now, if you remember back to algebra 2, or not really algebra 2, back to geometry, another way we can do this is if we find the slope of this line, and the slope of this line is the opposite reciprocal of this one, or these two. Because if the slopes are the opposite reciprocal, then they are what? Perpendicular. And perpendicular lines meet at a right angle. So there's more than one way to do this. Questions on this here? That's fine. It's been 2 years now. You got one of them? So any questions on this here? So we good with this? Yes? Okay. Midpoint. X1 plus X2 over 2 plus Y1 plus Y2 over 2. This is the midpoint formula. The midpoint is telling us where is the middle of the line. Midpoint. I have a feeling most of y'all remember this. Yes? Find the midpoint. So to find the midpoint, well, what are we going to do? We're going to take the 2x value, so well, negative 9 plus 5 is, over 2 is, so that gives us the x. How about the y? Over 2. So our midpoint is, that's it. Questions on this here? And I believe for what you're going to do on the homework, it's just mainly going to be asking about the midpoint, just finding the midpoint, find the distance, and then find the midpoint. Yep, that's it. Da-da. And that's it. Questions on this here? So we'll look at the application, or at least one of these application problems. So the first one is this here. A football quarterback throws a pass from the 28-yard line to the 40-yard line from the sideline. A wide receiver catches the pass on the 5-yard line, 20 yards from the same sideline, as shown in the figure. How long is the pass? Can anybody tell me why this is not realistic? What is the trajectory of that ball? It arcs, doesn't it? Any pass, anything you do has an arc at some point, yes? Even if you throw it as hard and as fast as you physically possibly can. If they actually tracked it, it still has an arc. Because even a missile, which is traveling faster than a human arm can throw, still has an arc. A bullet shot out of a gun still has an arc. So if we take some of the reality out of this, it's still going to have an arc. But we're going to assume that those things aside, he threw an absolute bullet, defying all laws of gravity, straight to him. How would we find the distance? Or how long is the path? Well, we would use the, kind of gave it away, the distance formula. So the distance equals to the square root of minus 5. Well, 40 minus 20 is, and this is going to be 23. Now, I can do 20 squared in my head. That is, so we can add those together and get the square root of 929, which is approximately, it's going to be 32. No, I think it's 32. It's probably closer to 33. 30.47. I knew I was getting a little high. A little too big of numbers. 30.47 yards. And that's it. Questions on this here? We good with this? And using a calculator, they are rounded to 30 yards. And that's it. An example, the scale along the goal line does not appear normal. However, if you use some coordinate geometry to solve real-life problems, you're free to place the coordinate system in any way that is convenient for the solution of the problem. That's it. That's all we are going to do.